Okay, so we're back with question 9 on this paper, the final question. Prove that, I'm not even going to read it out, prove that all of that is just equal to tan theta. Right, it was all just written, it was all the same as tan theta, why don't we just write tan theta? For all values of alpha. Oh no. Right. Well, it's you can see this theta minus alpha appearing all the time in there. So you get that this must be about using those sine A plus B, cos A plus B formulas. We're going to have to start with the left-hand side, and we're going to have to just go for it. It's going to get messy. It's going to take up lots of space, but hopefully it'll then all work itself out. So we start with sine of theta minus alpha, which is going to be sine theta cos alpha minus cos theta sine alpha. I'm not even going to fit this on here, am I? Then we've got plus 3 sine theta. And then we've got, cheating a little bit there, then we've got plus sine theta plus alpha, so that is sine theta cos alpha plus cos theta sine alpha. Looks like the other revision session having a break, but we're not yet. There we go. So that's the top line, all expanded. The bottom line is we've got cos A minus B there, so that's cos theta cos alpha plus sine theta sine alpha. Remember, it's the opposite to the sine in the middle. Plus 3 cos theta plus cos theta cos alpha minus sine theta sine alpha. Right. That looks horrendous until we realise that actually this is going to simplify loads. We have sine theta cos alpha appearing there and there on the top line. So actually all we've got is twice sine theta cos alpha. We have minus cos theta sine alpha and plus cos theta sine alpha. So they cancel each other out. And we only also have the plus 3 sine theta. So the top line simplifies down to that. The bottom line, something very similar happens. We've got cos theta cos alpha appearing twice. 2 lots of cos theta cos alpha. And we've got 3 cos theta appearing there. Okay. And then, if we look at that, we see what's happened here is we've got sine theta appearing as a common factor at the top, and cos theta appearing in both terms on the bottom. So now we want to factorise. We take sine theta out as a factor at the top, twice cos alpha plus 3. We take cos theta as a common factor at the bottom, twice cos alpha plus 3. And of course the factor in the bracket is the same top and bottom, so that just cancels out. Leave us with sine theta and cos theta, which is tan theta, which equals the right hand side, as we were hoping. It actually wasn't that bad at all, was it, once you got into it? The worst thing was being organised about writing out that first bit and fitting it across the page. Because if you've only got a tiny little pad like me, you're in all kinds of trouble. Okay, part 2 said find the exact value of that. Remember, OCR, although they don't seem to always perfectly stick to it, have a policy with their numbering of questions. Do you know this? That how they use A, B and C, or 1, 2 and 3.
I's are separate sections and then A and B should follow.
It's the other way around. If it's A and B, then that's related to the same topic area, but they're independent parts of a question. So you can do B before you do A and so on. If it's parts 1, 2 and 3, then that means there's a flow through the thing. That part 2 refers back to part 1 and uses stuff from part 1. So that should be our hint in this. And you try and compare what's going on here. We notice that we've got 150 seems to be a common theme. That's one less than 150, that's one more than it. So it looks like that's 150 minus 1 and 150 plus 1. We then notice we've got the number 4 is a common factor on the top. And on the bottom line we've got 3 as a common factor. So let's just try and work through it, see if we can tidy up as much as we possibly can. What we're saying is that we've got, in fact I'm going to write it out in a little bit more detail, we've got 4, that sine 149 is the sine of 150 minus 1. We then had 12 sine 150 and 4 sine 150 plus 1. And the bottom line of our fraction had us doing 4 cos
3.
Was it 3? Sorry. So it was 3 cos 150 minus 1 plus 9 cos 150 plus 3 again cos 150 plus 1. So that's just copying out the question in effect, but noticing the link between part 2 and part 1 that we already had. Now we notice that this is just the same as the top. Well, it's just the same as 4/3 of that thing that we started in part 1. So are we okay to make the step here that says that this is 4/3 of tan 150? I've not done too much there, is that okay to make that move at this point? We notice that this is just 4 times all that was going on in that original part of the question, and the bottom line is 3 times that. And the whole thing was worth the same as tan theta, so it must be 4/3 of tan 150. And your calculator should tell you the value of tan 150. You could kind of do it from the symmetry if you remember tan of, which would be tan of 30. So it must come out as being negative. Minus root 3 over 3 it comes out as. So we've got 4/3 of minus root 3 over 3. So minus 4/3 over 9 would be the exact value. There you go. And of course, if you still haven't got a calculator that gives you exact values of 10 things, then you need to remember your 30 and 60 and all those ones and work out how to get there. But I'm not sure there are many of you. Does anybody not have a calculator that will give you an exact value of 10 150?
No, I don't.
I could lend you one if you want to borrow one in the exam. I think it's worth having one that will do it. Right, that's that. Now, what about the next part? Part 3. It is given that k is a positive constant. Solve for theta between 0 and 60, and in terms of k, that equation. Yikes. Right. I think I want to write out the question here. So it said sine 6 theta minus 15 plus 3 sine 6 theta plus sine 6 theta plus 15 over cos 6 theta minus 15 plus 3 cos 6 theta plus cos 6 theta plus 15 equals k. Well, what do we get from this? Well, the first thing that we should get from this is actually that 15 is a complete red herring. It's irrelevant, isn't it? 15 makes no difference, because what we said right at the beginning was that this bit here is equal to tan theta for all values of alpha. Doesn't matter what alpha is, it's equal to tan theta. The fact that alpha is 15 is completely meaningless to us. It doesn't make any difference. Notice we're between 0 and 60, by the way, in there. That's maybe worth mentioning, worth noting, because that will become important in a moment. Right, so the 15 is irrelevant. If we ignore that, then it looks just like the thing we started with, so it just means what we've got is tan 6 theta is equal to k. So if we think how might we solve that equation, 6 theta would be the inverse tan of k. There must be a joke in here somewhere about bringing out the big guns to solve this one. It's a tank. Sorry.
Wow. That was strenuous.
Right. So we've got that. I liked it. Theta. We've got to find the values of theta that fit this between 0 and 60 degrees. If we think, what would our calculator say at this point? Well, what do we know about k? K is a positive constant. So knowing that, I am sorry, I know not all of you like the cast diagram, but I do. Yes. So based on a cast diagram thing here, if we'd done inverse tan of k, it would have given us two solutions. One of them there, and one of them in there, and that would be whatever our calculator said about inverse tan of k, and so would that angle there. That would be what our calculator said. Or, if you're thinking about your graphical method, how does it look? your graph is doing that, isn't it? Yeah? And we've just done inverse tan of some number, which was positive. So I don't know where k is, but it's there somewhere, up there. And it's given us one solution in the range 0 to 90, and another one between 180 and 270. Because there's 90, there's 180, 270 is there, and 360 is there. Is that okay? So this has given us two solutions. And the relationship between those two solutions are, one of them was between 0 and 90, and the other one was 180 plus whatever our calculator said. So those were the two solutions that we got. Bearing in mind, because we've been told that theta is between 0 and 60, we need to consider all the solutions of 6 theta between 0 and 360. Does that make sense? Because if theta is between 0 and 60, 6 theta is 6 times that range. So they would be the solutions that we could potentially get. It doesn't matter what value k is, all that matters is it's a positive value, so it will give me something between 0 and 90 from my calculator. I know that for any positive value. So 6 theta is these two solutions, so theta is a sixth of these two possible solutions, which gives me 1/6 of the inverse tan of k, and a second possible solution, which is 30 plus 1/6 of the inverse tan of k. And at the end of a Core 3 exam that you just slaved your way all the way through, it doesn't feel like a particularly satisfying way to end, but that's it. That is the final answer for those two bits. That's maths.